Okay, so I'm putting together just a video of this rationals review packet to help you prep for the re-exam if you want to. There's an old polynomials review packet with video. Here's the rationals review packet with video, and also I encourage you to go back and look at your polynomial notes homework links and your rational note homework links, just in case this review packet misses anything specific. You can't ever hit every single topic, but this one's just a verbal approach. When the square of a number, that's x squared, is decreased by 9, and then divided by 6 less than twice the same number. So here's 6 less than twice the same number, the result is. So this is just, once you get past the verbal part, it's just simplifying a rational by factoring and canceling. Okay, so first of all, an excluded value, if that ever comes up, would be 3, because that makes your denominator 0. They don't talk about that in this particular problem. This just reduces to x plus 3 over 2. So that's not 3 more than twice the number. That's not 1/3. If anything, it's 1/2 of something. 1/2 of 3 more than the number. There's 3 more than the number, and to take half of something, you divide it in 2, so it's number 3. Okay. The parent graph of a rational function to review is 1 over x. It's got an asymptote on the y-axis and the x-axis. It's got 1, 1, and -1, -1. So this has a few transformations. Number one, if you subtract 1 within the function, that's a horizontal shift right 1 unit, which is going to take a vertical asymptote and move it right 1 unit. So the new vertical asymptote will be at x equals 1. This 3 is going to stretch it vertically by 3. So 1, 1, it's 1 unit up, is going to be stretched to 3 units up. That'll now become 1, 3. And this one that was 1 unit down, tripled, will become 3 units down. So -1, -3 is where those will now go. Actually, that 1, 1 had been moved over to 2, 1, so it's going to be 2, 3. And the -1, oh, the -1, -1, with the shift right, actually moved over to 0, -1, so that's actually now going to be 0, -3. So maybe we want to track those points. So our two parent points are 1, 1, and -1, -1. The horizontal shift, horizontal always affects that. That'll make that 2, 1. And then it'll make that, shift it right 1, will make that 0, -1. Then the vertical stretch by 3 will change the y-coordinate times 3. And then that's a shift down 2, which is going to make your y-coordinate down 2. So 2, 1, and 0, -5. And so the shifts affected your asymptotes as well. So the shift right 1 moved your vertical asymptote right 1. The shift down 2 moved your horizontal asymptote down 2. And so that kind of gives you like a new origin to work from. And then your points are sort of nestled in the corners, and they tell you 2, 1. And that's going to do that. And 0, -5. Oops, I'm going to do that 2 and 1 right, because I did it from the asymptote. So 2, 1 is there. And 0, -5 puts you right there. So describe the transformations. 1, 2, 3, got it, and in the right order. Then sketch a graph. Be sure the asymptotes, x equals 1, and the y equals -2 are clearly labeled, and the intercepts. So the y-intercept is -5. So that's labeled. The x-intercept, we don't actually know exactly what it is, but we can find it algebraically. The x-intercept is when y equals 0. So if that equals 0, we just would solve. Add 2 to both sides, and then maybe cross multiply. Put that 2 over 1 and cross multiply, so we get 2x minus 2 equals 3. Add 2 to both sides, we get 2x equals 5. Divide by 2, x equals 2.5. So the x-intercept is 2.5. That took a little more algebraic work. This y-intercept ended up being nicely there, but the x and y-intercept, asymptotes labeled, I followed all the instructions. Okay? A complex fraction, the way I taught you to solve this is by looking at the many denominators within the fraction. So one denominator is x plus y and the other denominator is x. So the least common denominator of the two of those would be just that. So I'm going to multiply the numerator by that, and I'm going to multiply the denominator by that. In the numerator, that requires distributing. When I distribute to the first term, the x plus y's will clear, leaving just 1 times x. And on the second distribution, your x's will cancel, leaving just minus 1 times x plus y. Critical to keep that x plus y in parentheses. And your denominator, there's only one term. When we multiply x plus y times y, we don't need to multiply anything out. Just keep them as separate factors, because we don't have to add or subtract anything down there. They're just factor times factor times factor. Up here we had a binomial with a minus sign in between, so we had to distribute, and because we have to simplify that. So it'll be x minus 1x minus y. So you're distributing negative 1. And then you have x plus y, x, and y. So your x minus x cancels, and there's your answer. Now, is that there? Well, the y's cancel too. So the y and the y, that just leaves negative 1 up top over x plus y, which is the same as this one. First of all, it's the only one with negative 1 up and top, but they could have put the negative on the bottom. But they did keep it on top, and x times x plus y, they just happen to multiply out, x squared plus xy. Simplifying, just doing adding and subtracting, you need to know you need a common denominator. So before you look for common denominators, you want to factor accordingly, x minus 4x plus 4. This already has an x minus 4, this already has an x minus 4, and this one has a 4 minus x. So here's that property of they're almost the same, but not exactly the same. We want to switch the order, not of these two, we like that order, but this one. To switch the order, you pretty much negate the numerator, and then that'll change it to an x minus 4. So now they all have an x minus 4 in common. They still need the common part of x plus 4. So this one needs an x plus 4. And this one needs an x plus 4. And then x minus 4x plus 4, x minus 4x plus 4, x minus 4x plus 4. Now, we're not solving, we're simplifying. If it was solving, we could drop all our denominators. Since it's simplifying, we're really just, now we can crank out the numerator. So this is 2x plus 8 minus 1. Distribute your negative 3 minus 3x minus 12 all over your common denominator of x minus 4x plus 4. Simplify that numerator just a little bit more, you get negative x. 8 minus 1 is 7, 7 minus 12 is negative 5. So you may see it like this. You may also see a negative 1 factored out of the top. Either one of these would be an okay final answer. Solving, this is a particularly easy solving one because you could get a common denominator on both sides and then drop them, but because it's a single fraction equaling a single fraction, we can cross multiply. And then it's a quadratic, so you just have to subtract your 30x over and add your 60 over. That's going to make 8 minus 30 is negative 22. Now, to solve this quadratic, we could factor, we could do the formula, or we could realize those are big numbers, let's make our life easier and divide both sides by 2. That'll clean it up to x squared minus 11x plus 30, which now factors nicely into x minus 6 and x minus 5, which gives me answers of x equals 6 or x equals 5. And if you check those, neither of them gives you an extraneous. If 2 came up, we would have to reject it. If negative 4 came up, we would have to reject it. But both of those are good. So the smaller of those two solutions is 5, and so we would pick that one. That's tricky because there's 2 solutions that are there. You have to read the detail of the smallest solution. Okay, the value of the inverse at x equals -1. So there's two ways you could do this. You could write your own inverse and then plug in -1. We're going to write an inverse on number 10 down below. So if you know that in the inverse you would plug in an x of -1, that means in the original you'd plug in a y of -1. So if I just plug in -1, I'll actually get the right value. So they're giving us the original, they're saying on the inverse x needs to equal -1, and we're looking for that y value, which means on the original you can plug in a y of -1 and it'll give us the x value, which will correspond. So just with this I'll cross multiply, add 2x over to the right and that'll give you 3x, subtract 8 over to the left, so it'll give you -7, and you get x equals -7/3. Another option for this one would be to just plug in the function x plus 8 over 2x minus 1. Take a look at your points. Now mine's changing by 30, so I want to definitely change my table set and count by ones. Okay, and on the inverse they want x is -1, so on this one they want to look for where y is -1, which is actually hard to find because there is no y of -1. So that doesn't exactly work for you because we're not going to get an x of -7/3 on here. It skips over -1. So I guess we could look at this graph, and if we want to know where y equals -1, we can just graph y equals -1. And remember, this says x equals -1 because this is talking about the inverse. We're talking about the original functions, what we typed in, so we're looking for where y is -1. And if you graph that and find that intersection, then you'll see the -7/3, -2.3 repeating. Okay, this is just simplifying. So most people would probably multiply this out, and then remember to distribute your subtraction. What you also could do is you could notice the x plus 5 in common, and you could factor that out. And then your remaining factor would be 3x minus 7 minus an x plus 1. And then the denominator factors into x minus 4, x plus 3. This part's going to get cleaned up to 3x minus x, which is 2x, and -7 minus 1, which is minus 8. Then that's going to get cleaned up to 2 times x minus 4. So this x minus 4 and that x minus 4 cancels, and so it simplifies to 2 and x plus 5 up top over x plus 3 in the bottom. Expressing the sum, gosh, there's no solving on any of these. For the sum, we just need a common denominator again. This is typical factoring. This is GCF factoring. This one needs an x. This one needs an x minus 1. So your numerator becomes x squared minus 6x plus 8x minus 8. All over x plus 4, x minus 1. Clean that numerator up just a little bit more, x squared plus 2x plus 8. And then that's not factorable, so nothing else will cancel. So this over that is your final answer. Complex fractions again, many denominators, 5, x, and x. So the least common denominator is 5x and 5x. In my numerator, when I distribute, I get 10x. When I distribute there, my x's will cancel, and I get 10 times 5 is 50. On my denominator, 5x times the first fraction, the 5 will cancel, so x times x, I'm not going to fully cancel that 5 because I need it for my next distribution, but x times the leftover x is x squared, and when I distribute here, the x and the x will cancel. Negative 5 times 5 is negative 25. So I can factor out a 10 up top, and I can do difference of perfect squares on the bottom, which allows me that, and my final answer is 10 over x minus 5. Last but not least, writing an inverse. switch the x and the y. Solve for y, which is tough because y's are in multiple spots, so I'm still going to cross multiply. But I got to get my y's all on one side, so I'm going to subtract this y over, and my non-y's over to the other, so I'm going to bring this negative 2x over. So the left side's xy minus y, and the right side is, that's gone and that's gone, negative 2 minus 2x. If we can't combine the y's, remember we're solving for y, so we got to combine the y's if we can, if not factor. Take out a y and you're left with x minus 1. And then divide the x minus 1 over. So y equals negative 2 minus 2x all over x minus 1. And then we want the right notation, so f inverse of x equals negative 2 minus 2x over x minus 1. Maybe up top they would factor out the negative 1. So it would be 2 plus 2x. And that would just be for up here is the sake. But there's the inverse.